Okay, Chapter 3 in the OTCO workbook. We're finally up to the flow rate problems. There are 5 of them at the end of the homework. Our flow rate formula is flow rate Q equals area times velocity. So Q equals A times V. I'm not sure why we use Q to express flow rate, but that's how it's written. So all of these problems can be solved with that simple formula. There's just going to be some converting to find the numbers to plug into the formula. So the first one is pretty straightforward. It is simply asking us to calculate flow rate in cubic feet per second. So we're trying to solve for Q, so we need to know we need a number for A, or area, and we need a number to plug in for V, or velocity. So we're given the velocity right here, 8 feet per second. How do we calculate the area? Well, we are given dimensions, 3 feet and 15 inches, to calculate a cross-section of area. So if you can think of this channel like this, it's 3 feet wide, and it doesn't really matter how deep the channel is. It only matters how deep the water is flowing in the channel. So, and we are given that in inches, 15 inches deep. So in order for this formula to work, we have to convert 15 inches into feet, because we need an area in square feet. So the very first thing I'm going to do is convert 15 inches into feet. I know there are 12 inches in a foot, so 15 inches is going to equal 1 foot 3 inches, or 1.25 feet. You just get that by dividing 15 divided by 12. So now I have my area, which I can calculate by multiplying 3 foot wide channel times water depth of 1.25 feet equals 3.75 square feet. So now I have my area. I was already given my velocity, so my flow rate is going to be area times velocity. There's my area there. So 3.75 square feet times velocity, which was given here, 8 feet per second. So 8 feet per second, so 8 feet over 1 second. To make this multiplication a little easier, I'll put this 3.75 square feet over 1. Now remember, I'm multiplying square feet times feet. That's going to give me an answer in, and you can think of linear feet as feet to the first power. Square feet squared times linear feet is going to give me an answer in cubic feet. 3.75 times 8 is going to give me 30 feet, and then all over 1 second, or 30 cubic feet per second. And that's what they were asking for. Okay, our next problem. Again, our formula, flow rate equals area times velocity. This time they are asking us to calculate the velocity, or v, so we need to rewrite the equation. If we want to rewrite this equation, if we want velocity on one side, what can we do? We can divide both sides of the equation by a, right? Hopefully this is starting to come back to you all. So we can rewrite this formula as velocity equals flow rate divided by area. Now let's think about this a little bit further. Flow rate is going to be eventually expressed in cubic feet per second, or cubic feet. We can express gallons. We're given gallons, but we can convert that to cubic feet. And area, we know, is expressed in square feet. If we're dividing a cube by a square, or a number with an exponent of 3 divided by a number with an exponent of 2, remember we subtract the exponents, that would give us 1. So the velocity would be in linear feet, right? Linear feet. Is this hopefully starting to make sense and sink in a little bit? So, okay, let's go ahead. First thing I'm going to do is calculate area, and I'm given a 9-inch diameter pipe. Well, guess what? I've got to convert that somehow into square feet. Okay, 9-inch pipe, 9 inches in diameter. Again, it doesn't matter how long the pipe is, I'm only trying to calculate the area of the circle, which would be a cross section of the pipe. Just like in the last example, we were trying to calculate kind of a cross section of the channel with water flowing in it. This time we're trying to calculate the cross section of this pipe. It's 9 inches in diameter. 9 divided by 2 equals a radius of 4.5 inches. Now I can use my formula for the area of a circle, pi times the radius squared. So pi 3.14 times 4.5 inches times 4.5 inches, that's the radius squared, is going to give us an answer in square inches. Let's go ahead and do that. 3.14 times 4.5 times 4.5 equals 63.6 square inches. But in order for my formula to work, all these numbers have to be in the same unit of measure, or in feet. So let me convert 63.6 inches into feet. I know there are 12 inches in a foot, so 63.6 square inches but I'm not converting it into feet, I'm converting it into square feet. And how many inches are there in a square foot? 12 times 12, or 144 inches. So I have to divide 63.6 inches by 144 square inches to get 0.44 square feet. So my area in my formula velocity equals flow rate divided by area. My area equals 0.44 square feet. So I've got one variable done. Now I've got to figure out flow rate. Well, my flow rate is given as 2.5 million gallons per day. How can I convert that into cubic feet? Well, first of all, let me write it out. 2.5 mgd can be written as 2,500,000 gallons. Now, I'm ultimately trying to calculate velocity in cubic feet per second. So I'm going to convert gallons into cubic feet, 2,500,000. I know that there are 7.48 gallons per cubic foot. Which I could also write, if you 7.48 gallons in 1 cubic foot. Now remember, when I divide by a fraction, I'm going to multiply by the inverse. This is where that comes in handy. I can rewrite this as 2,500,000 gallons times 1 cubic foot over 7.48 gallons. And what I'm ultimately left with is, if I divide 2,500,000 gallons by 7.48, I'm going to get an answer in cubic feet. So let's go ahead and do that. 2,500,000 gallons divided by 7.48 comes out to 334,225 cubic feet. Now remember, this is per day, but I'm trying to get it down to cubic feet per second to plug into my formula. So how do I do that? Well, how many seconds are there in a day? Now I happen to know off the top of my head, and it probably is on the conversion sheet, but if you don't know off the top of your head, it's pretty easy to figure out. 24 hours in a day times 60 minutes in an hour times 60 seconds in a minute equals 86,400 seconds in a 24-hour day. So if I want to convert cubic feet per day into cubic feet per second, I just divide by the number of seconds in a day. If I do that, I get a flow rate of 3.9 cubic feet per second. So now I've got my flow rate in cubic feet per second, and I've got my area in square feet. Remember my formula, I rewrote it as velocity equals flow rate divided by area. I can finally do my final calculation here. 3.9 cubic feet per second divided by 0.44 square feet is going to give me a number in feet per second. 3.9 divided by 0.44 gives me 8.9 feet per second. So a lot of steps here. You're doing a lot of conversions, converting inches to square feet and gallons into cubic feet and days into seconds. It's actually not really all that difficult, the math part. It's just a lot of steps, so you need to be careful and think it through logically and make sure that you're not missing any steps along the way.